All right, Emily, you're only going to see you're going to only see my chin down because I want you to be able to see my number line. So here's a video of how you can approximate a non-perfect square. Let's say we have the square root of 15. The first thing we do is we look at our number line to find the two perfect squares that are on either side of the square root of 15. That will be the square root of 9 and the square root of 16. Then I determine what the square root of 9 is, which is 3, and 16, which is 4. Those are the two integers that this non-perfect square will fall in between. And right in between 3 and 4 is 3.5. So now I have to ask myself, how far is the square root of 9 from the square root of 15? That is 6. And then the square root of 15 to the square root of 16 is only 1 away. So then, once I determine how far away these square roots are from one another, I need to figure out, will the square root of 15 be closer to the whole number 3 or the whole number 4? It's going to be closer to the whole number 4 because the square root of 15 is only 1 away from the square root of 16. The square root of 15 is 6 away from the square root of 9. So I'm not going to try any of these decimals. So I have these four: 3.6, 3.7, 3.8, and 3.9 to try out. Could also try out 3.5. But since 15 is only 1 away from the square root of 16, I'm going to try 3.9. So then I multiply. 9 times 9 is 81. 9 times 3 is 27, plus 8 is 35. Put a 0 here. 9 times 3 is 27. 3 times 3 is 9. Plus 2 is 11. And then I add. And I move my decimal over. So 15.21. That is pretty close to 15. So the approximate square root of 15 is 3.9. So my first step is to find the square roots that are on either side of the non-perfect square. Then I determine, my second step is what the square root is, so I can figure out the integers that it's between. Then my third step is to see how far the square root is from the perfect square root is from the non-perfect square. And then after I do that, my fourth step is to try out one of the decimals, square it, and see how close it is. All right, Emily, I hope this helps.